Bismillahirrahmanirrahim. It is written in the statement that alpha, beta are roots of this equation, and we have to form an equation. Required equation will have alpha square, beta square as roots. So our task is to find we will find the sum of roots by using formula alpha plus beta is equals to minus p over a of the given equation. So according to the given equation, you will see that a is equals to 1, b is equals to p, and c is equals to q. So by using the formula, so we would write p over 1, that is minus p. This will be the value of alpha plus beta, and alpha beta will be c over a by formula. So it will become q over 1, that is equals to q. So we have gotten two values, one for alpha plus beta, second for alpha beta, and we will use these sum and the product of roots of given equation. This is the sum and product for given equations. So what we will do, that we will find the sum of required equations, sum of root, that is equals to alpha plus beta whole square minus 2 alpha beta. We will use the given values of alpha plus beta whole square minus 2 times q. So we already know that alpha square and beta square is equals to whole of this formula. So we have calculated sum of required equations. Now we will find alpha square beta square as the product. This was the sum of required equations, and this will be the product of required equations, alpha beta whole square, that is equals to q whole square, that is equals to q square. So we will put it into the formula to generate the equation. So that formula is x square minus sx plus p is equals to 0. So putting the values in this expression, we will get the equation. Like equation will be x square minus s dash will be p square minus 2q. This is the sum value of the sum of roots, and the product of roots is equals to q square. So this will finish the statement of the question. This is the required equation. This is the required equation. So this is A part. Similarly, we will use same alpha plus beta and alpha beta for part number B as well. So according to part number B, required equation has roots alpha over beta minus comma beta over alpha. So what we will do in the very first step, that we will find the sum of roots like this one, and we will take the LCM. alpha beta. So it will generate alpha square plus beta square by taking LCM, and then this whole expression which is in the numerator, alpha square plus beta square, this is always equals to this expression. We have all learned in the previous topics. So once we will get it, we will substitute the values of alpha plus beta, and like alpha plus beta in the statement above, as I just worked out in the previous part, same will be used again from equation number 1, that is alpha plus beta is equals to minus p. Right? So we will use this value. This is value of alpha plus beta. And we also have another value, that is alpha beta. This is q. So we will use this second value as alpha beta equals to q. So we will substitute these two values into this equation to find the sum and product of required equations. So by substituting alpha plus beta from equation number 1, this is minus p whole square. Alpha beta is q. Alpha beta is equals to q. So this is p square minus 2q divided by q. It is the value of s dash. So simply by substituting the values, we will get the value of sum of roots of the required equation. Similarly, we will find the product. That will be much simpler because alpha beta dot beta over alpha, product of the roots will generate 1 because all these terms will be cancelled out. So we will get 1. So the product will be 1. And the formula to generate equation is x square minus sx plus p. So we have already marked them s dash and p dash to make the difference from the sum of root and product roots of given equation and the required equation. So simply substitute the values now. If you will put it here, it will be p square minus 2q divided by q times x plus 1 equals to 0. Now simply if we will multiply with q all the terms, the expression will be reduced to qx square p square minus 2q times x plus q equals to 0. So we will multiply with q on both sides of this equation, and consequently we will get this required equation whose roots are alpha over beta, comma beta over alpha. So this finishes the question.